Daniel. Why are all the lights on? Lights everywhere.
So this one is easier than the first one, but it looks a little complicated, but it's more straightforward. This one just have to do with ranking. So all you have to do is they will still give you your normal X and Y variables. As I said yesterday, correlation is about checking or finding the relationship between two variables and to see the extent of the relationship, whether it is strongly positive or strongly negative, and their values are between -1 and +1. So, but in this case now, you have two variables, and what you are looking at is the relationship through ranking. So for this SPEARMAN'S rank order, you rank the variables of the X and Y, then the ranks, then you now find the difference between the rank, then you now find the square of the rank, and you now solve. So it's very straightforward. So I believe the confusion from the material is the explanation is not clear on how they arrived at whatever rank they use. I think that was the issue I also saw before, and I had to check through YouTube, and I was able to get it. Everyone should just open to the example in the note, the lecture notes. Open to the example. I think page 201. Open to page 201. Page 201. You see the SPEARMAN rank order correlation. So we'll just work with the example. So I'll write the formula clearly. So as I said yesterday, the first things first is to write out the formula. So after you write out the formula, then you now try to break down the formula. So you write out the formula, then you bring your table. So you put whatever variables they gave you in your table. Then you find whatever you are looking for from the variables according to the formula you have written down. Then before you now substitute. So I'll write out the formula. So the formula to solve this. So it can be R, but the RHO is just telling you that what you are doing is rank order correlation coefficient. So RHO is telling you that it's rank order coefficient. So the formula is 1 minus 6 summation of d square all over n bracket open n square minus 1 bracket close. This is the formula, straightforward. So the n is just number of variables given in the question or in the example. So from the question given, the number of variables there is 10. So if you press your note,
sorry, Mr. Shallom, can some of us mute? It's distorting the whole process. Please.
Okay, let's everybody that needs to mute here. Are we okay now?
Yeah.
Okay. So I said the n just represent the number. So let me just write it out. N is equal to the number of variables given in the question. So that is what N stands for. Then the D is equal to difference between the rank variables. So when we draw the table, you understand the meaning of the D properly. So I'll just go ahead and I'll draw the table. So we have X and Y as usual. So X represents one of the variable, Y represents the other one.
Please, can someone brief me a little bit? I'm just joining. I'm having a network issue just from the beginning. Please, I'm sorry.
Sorry. So we have the serial number and we have 10 variables. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this the serial number, then I will just impute the values for X and Y according to how it is given in the material. So 51, 44, 70, 32, 65, 67, 19, 71, 45, 80. And for Y we have 49, 41, 45, 31, so this part now is where is very important. But why? This where the confusion. So this Rx is rank of X. These are the X variables. To rank them, we'll carry the rank of Y is 80. X 80 highest. 80 is the highest. 80 the next highest one.
This network issue, is it from my own end or is general?
Then And then I think the network in my side is. I think it's your end. That place is okay.
It's your end. Clear here. I think it's your end.
Okay, thank you.
Okay. So the next highest number is 70. So this 70 will now carry rank. Remember, we are doing the rank for X now. Rx means rank of X, so it will carry rank 3. Then the next highest number is 67. It will carry rank 4. The next one is 65. It will carry rank 5. The next one is 5. The next highest number is 51. It will carry rank 6. The next one after 51, the next highest one is 45. It will carry rank 7. Then the next one is 44. It will carry rank 8. Then the next one, the next highest number after 44 was the next one is 32. It will carry rank 9. And the lowest one will carry rank 10. So this is the ranking for X. So Rx means rank of X, and the numbers are ranked according to highest. So highest value in X will carry rank of 1, and so on and so forth. Then we'll go to Y, rank of Y. So the highest number in Y is 75. So 75 will carry 1. Then the next highest number after 75 is 64. So 64 will carry the rank of 2. Then after 64, the next highest number is 61. It will carry the rank of 3. After 61, the next highest number is 50. It will carry the rank of 4. After 50, the next one is 49 to carry the rank of 5. After 49, the next one is 45. It will carry the rank of 6. After 40, the next one is 41. It will carry the rank of 7. Then after 41, the next highest number is 31 to carry the rank of 8. Then the next one is 21 to carry the rank of 9. And the last one is 11 to carry the rank of 10. So any question on this ranking?
Yeah, please, I still do not understand the ranking, please.
Okay, let me go over it again.
Okay, thank you.
So this is X. This X and Y we are given to us in the question. So we are now trying to now find the rank for X and Y. So for X now, how we rank them is, if you look at this X, which one is the highest? Which number is the highest in all the variables in X? Which one is the highest? The highest is 80.
80.
Because the 80 is the highest number in X, it will carry the rank of 1.
That's 71 with
Then
the
the next highest number after 80 is 71. So it will carry the rank of 2. Then the next highest number among all these numbers is 70. It will carry the rank of 3. So that's how we rank them. And the same thing for Y. If you look at the variables in Y, the highest number is 75. Because 75 is the highest number, it will carry the rank of 1. So RY means the rank of Y. So we rank them according to the variables. How the higher variables will carry higher ranks, and it goes from the highest to lowest. So from this, it goes descending order. It follows a descending order pattern. So from highest to lowest. So the highest value we carry the first rank, and it keeps going down till you get to the last rank. Is it clear?
Yes, please. Thank you.
Okay,
Thank
so
you.
let's just
Thank you.
let's put the next one. So we are looking for D. So the next variable we'll look for is D. And I said D is the difference between the ranks. D is the difference between the ranks. So you are just subtracting. So 6 minus 5 will give us 1. So we are just finding the difference between the ranks. 1. 8 minus 7. 1. 3 minus 6. Minus 3. 9 minus 8. 1. 5 minus 4. 1. 4 minus 3. 1. 10 minus 10. 0. 2 minus 2. 0. 7 minus 9. Minus 2. 1 minus 1. 0. I believe this one is clear.
Yes, it's clear.
Okay. Then we'll now find the last value. D square. So the D square is, we are just squaring this. We are just squaring this. So 1 square is D1. 1 square is 1. Minus 3 square is 9. 1 square is 1. 1 square is 1. 1 square is 1. 0 square is 0. 0. The minus 2 square.
How do we get the next table? Because I was hooked because of my network. Please, sorry, the D2.
Okay.
D square.
So the D, we got the D from subtracting Rx and Ry.
Okay.
That's how we got D.
Okay.
8 minus 5, 8 minus 7. Then after we got the values of the D, then we now square them.
Okay, I understand.
So when we square them, this is what we get. So remember from the question, look at the question, summation of D square. So we are finding the sum of this. So we'll just put our summation value here and we add everything. So when we add everything, that's 1 plus 1, 2 plus 9, 11 plus 1, 12 plus 1, 13 plus 1, 14 plus 4, 18. So the summation of this square is 8. So let me just bring the formula here and we solve. So remember our formula, RHO is equal to 1 minus 6 summation of this square all over n bracket n square minus 1 bracket close. So this is our formula. We'll just substitute. So all this table, all the stress we went through in this table is just to find our D square, and our D square is 18. So we'll substitute into this formula. So RHO is equal to, we'll put 1 minus 6 times D square 18 all over our n. I said earlier on, our n is the number of variables. Our number of variables is 10. So we'll put 10 into 10 square minus 1. Then we will now have it to be equal to 1 minus 6 times 18 is 108 all over 10 into 10 square is 100, 100 minus 1. Then we can just use our calculator to break everything down. So it will be 1 minus 108 all over 10 times 99. 100 times 1 is 99. Then 1 minus 108 over 990. So when we do 108 divide by 90, so what we are doing, okay, let me just proceed. So 108 divided by 990 is 0.109, which is equal to 0.891. So we have a correlation value of 0.891, which is positive, a strong positive correlation value, meaning that there's a positive relationship between the two variables. Any question?
Okay, I have a question. According to the formula, the 1 minus is only applicable to the 1 up. Like the 1 minus does not really, it's not like the total formula. But according to this one that was solved, at the end of the day, you kept serving the 1 for the whole, and then eventually you had to take away 1 from
I think
the whole thing. So I don't really get. Is it the one only for
let me
one
explain, sorry,
or for everything?
I think I'm coming.
You get what I'm trying to say?
I know what you're saying. I get it. So I think the formula is more clear this way. We are doing 1 minus the. I told you the arrangement of everything in the book that is causing confusion. So I think the formula is more clearly represented this way.
Exactly. Yes. That's what I'm trying to talk about. It's better this way, so we won't get confused.
So I think it's the arrangement in the textbook that is causing the confusion.
Okay, so this one is better as a formula. So it's the whole thing. I just want to say that it's the whole thing that we are going to take away from 1. It's the one that we are going to minus last. That's the last step.
Yes.
Okay. All right. Thank you.
Hello. Hello. Sorry, the network delayed me. Can you please help me go through the table once again? How to get that RX, RY?
Okay, let me just go through it briefly so that we'll go through the second. Then there's somebody that asked me yesterday night about page 178. I think we can use a few minutes to also go through that one. Okay, so let me just go through the table. X, the variable they gave us. X and Y are the variables they gave us. So to get Rx is the rank of the variables in X. So X, we look at the variables, we look at the highest value, and we rank it as 1. So it's just like in a class, if you have a student that has the highest score, you give the person first position, right? So the next highest score will carry second position. So that's what you are doing to these variables. So since 80 is the highest, it will carry the position of 1. Then the next highest number, 71, it will carry second position. So that's how we rank them. So you're just looking at the numbers in X and putting ranks to them. The highest number, then the highest number will carry 1. The next one will carry 2. The next one will carry 3, and so on. And the same thing with Y. The highest value in Y will carry the rank of 1. The next highest value will carry the rank of 2, and so on and so forth. Then after we have gotten the ranks, we'll now subtract the ranks from each other. So when we subtract them, we get these values. Then after we finish the subtracting, then we'll square all the answers. Then we'll now find the sum of them all. Somebody has a question.
Yes. Good evening. Thank you very much. You mentioned that the summation of the whole answer, where you have 0.8 something, that is strongly positive. How do we know?
Okay. You are not in yesterday's class, right?
I was there.
Okay, let me explain. Correlation values are between -1 to +1. So the closer the value is to 1, that's +1, then the more positive the relationship. So since we got 0.8, what did we get? 0.891. 891. Is this 0.891 closer to 1?
But please, Shallom, yeah, okay. The paper is not showing.
I think it's this light issue. Sorry. Is it clearer now?
It's keep showing on and off, on and off.
Because somebody is not muted, so the person's page keeps coming. People are not muted. The one that should let everybody, let every one of us mute ourselves.
So this 0.891 is closer to 1. That's why I say strongly positive. If that we got an answer that is maybe 0.1, let's say 0.12, the thing is far away from 1. So we can say yes, there's a relationship, but relationship it is not strong. Yes to 0, it means that there's no relationship. So 0 means there's no relationship between the variables. So when you solve any correlation and you get 0, it means there's no relationship. Then if the thing either moves this side, it's going towards the positive. This side, it is going towards the negative.
Okay.
Any other question?
All right, thank you.
One more question, please. When they give us something like this, will it be stated like the formula to use? Will they tell us, okay, you should use this ranking or which one like to be stated right, or we can use anyone?
Let me just give you. We have three basic correlation. The one from what they give us in our note, I think they gave us 3. So the first one is Pearson product moment correlation, and that one is if they just give you normal values, normal 2 values, and we say continuous data. So when the data is continuous, that's normal 1 to 1.1, 1.2, 1.3, and so on. If they just give you those values, you know you are using the Pearson product moment correlation. But
sorry, tell me again, I don't understand. I don't understand what you mean by what.
I said if they give. Okay, yesterday I talked about continuous data. Continuous data, we have continuous and discrete data. Continuous data are data you can measure and the values are continuous. So we can have 1.2, 1, 3.2, and so on. Anything, if you measure using a weighing balance, the values are continuous. It can be 4.5 kg, 4.7 kg, and so on. So the values are not unique. It can be anything. Those are continuous data. But we now have discrete data. I use the example of, let's say, number of students in a class are 10. So each student represents 1. You cannot say in a class you have 1.5 students or 2.5 students. Then I talked about a dice too. If we have a dice have 6 sides. So the sides of the dice can only be either 1, 2, 3, 4, 5, 6 straight. You can't say the side of the dice is side 1.5. So those are discrete data. Their values are straightforward. It's something you can count directly. But continuous data that are continuous, they are data that are measured. So when you see just normal data, you can use the normal SPEARMAN. That's the first one, the one we did yesterday. If you just see, they just give you 2 values. But if they now talk about rank in the question.
Sorry, please, I still do not understand. How are we going to know that person products? Like, how? What's that thing that will make us the...
Yes, it's clear.
Okay. Yes. So now we are now doing deviation from mean. So each value of x will subtract the mean from it. So for example, 10 minus 13.5. 10 minus 13.5 is minus 3.5. Then 15 minus 35 is 1.5. So we are subtracting each value of x. We are subtracting the mean, this mean we got here, from each value of x. So when we do that, we'll get the following values: minus 2.5, minus 0.5, minus 1.5, 4.5, 6.5, 0.5, 2.5, 3.5, minus 4.5, minus 6.5. Is this one clear?
Yes. Yes.
So after that, we now square. We square all these values. When we square them, we'll get the following values: 12.25. That's minus 3.5 square. When you use your calculator, you get each of these values: 2.25, 6.25, 0.25,